This here the chapter name is linear inequation. So in linear inequation, again you will find equations which are very similar to the linear equation, but the rules for solving these inequations are slightly different from the rules of solving linear equation. And unlike the linear equation where we used to just get one single value of x, here you may get multiple values of x. So a linear inequation is a mathematical statement which state that one quantity is not equal to another quantity. So for example, if a equation involves symbols like this, x is greater than 7, this means it is a linear inequation. Okay, just for comparison, we can write a linear equation. Linear equation were in this form, like x plus 5 equals to 7. This is example of linear equation, while this is an example of linear equation inequation. So linear inequation mainly consists of symbols like greater than, less than, greater than or equal to, and less than and equal to. So this is symbol for greater than, this is symbol for less than, greater than equal to, less than equal to. Okay, these two symbols you're already familiar with. These might be new. So just an extra line below the symbol, greater than or less than symbol, means it is greater than or equal to, or less than or equal to. Clear? Okay. In this chapter, we just learn how to solve this linear inequation. So certain rules are required to solve linear equation, which we need to just understand. In fact, as we read through these rules, you'll also find that some of the rules are just interconnected. Am I clear? So it's not that we will be using every single rule here. In fact, we can just generalize it at the end so that we just use that rule. Am I clear? So let's see. First rule says that on transferring a positive term from one side of an inequation to the other side, the sign of the term becomes negative. For example, if I have equation like this, x plus 5 is greater than equal to 7. Okay. So solving this inequation means taking all the constant terms to the other side and leaving x on one side. So here we can say x is greater than equal to, so we take this 5 to the other side. So if I take 5 to the other side, sign changes for 5, it becomes minus 5. Solution for an inequation is x is greater than equal to 2. See, there can be many values of x which is greater than 2. So therefore we can also say that this is not one solution, there are many solutions. Okay, every number which satisfies this condition x is greater than 2 is a solution for this linear inequation. Okay, so this is different from a equation solution. Equation mein to we used to get equations like this, x is equals to 5. So there's just one solution. Inequations have multiple solutions. This is what we used to do with linear equations as well, right? Even in linear equation, if you're taking this 5 to the other side, like we just change the sign, positive becomes negative. So that's not a new rule. It's similar to what we have studied in linear equation. Next rule, on transferring a negative side from one side of the equation to the other side, the sign of term becomes positive. So if you're taking a number from left side to the right, so let's make an equation. X minus 5 is less than equal to 7. So here, if we take minus 5 to the other side, minus 5 becomes plus 5. So the final solution is x is less than equal to 7 plus 5, 12. If each term of an inequation be multiplied or divided by the same positive number, the sign of inequality remains the same. For example, if we have inequality like this, 2x is greater than equal to 5. So if we divide both sides of the inequality by 2, this side we get x greater than equal to 5 by 2. So the inequality remains the same. Inequality remains the same means there is no change in this sign, this symbol greater than equal to. Greater than equal to remains as greater than equal to. Means 2x greater than 5 implies that x is greater than equal to 5. The rule is only applicable for a positive number when you divide or even multiply by a positive number. This rule is not applicable for a negative number. something like this, minus 2x is equal to minus 10. Okay, if you remember, we used to do like this, and we still do like this. We divide both the side by minus 2. So minus 2 cancel. This side, it becomes 5. So x is equals to 5. Haven't we solved linear equations like this? And I think it's allowed. It's correct only, right? But can I do the same in linear inequation? If I have a linear inequation of this nature, okay, minus 2x is greater than equal to 10 or minus 10. Can I say, like, dividing both sides by minus 2, can I say x is greater than equal to 5? Is this okay? Is this allowed? No, no. We can't divide both the sides of an inequation by a negative number. If we do so, if we at all want to do so, we change the inequality here. It means greater than equal to is wrong. If you're dividing both the sides by a negative number, you change the sign, means you can write, you change the inequality. So you write x is less than equal to 5. So greater than equal becomes less than equal. Clear? You're familiar with the number system, right? I'll just ask you two simple questions. Which is a bigger number, 2 or 1?
2.
So can I say 2 is greater than 1?
Yes, sir.
Okay. Second question. Which is greater, minus 2 or minus 1?
Minus 1.
Okay. So minus 1 is greater than minus 2.
Yes, sir.
If it was allowed to cancel the minus sign, it would imply that 1 is greater than 2. Is that true?
No, sir.
That's why we can't cancel the minus sign. I hope that makes sense now.
Yes.
If sign of each term on both the side of the inequality is changed, the sign of inequality gets reversed. Okay, example, if you have number like this, x is minus x is less than 5. So if you want to change the sign, means why we change sign? We just to make x positive. That's the whole intention of changing sign. So if you write x as a plus x, minus x as plus x, okay, then you need to change sign even on the other side. 5 becomes minus 5. And just change the inequality. Change less than sign to greater than sign. Okay, so this is allowed. Clear? Very similar to the previous case. It's basically like we are dividing by minus 1 on both the sides. So it's not like two different rules. It's the same thing. If you have an inequality like this, minus x is greater than equal to 7. If you want to change sign, like changing sign is only required to make x positive. Okay, so x positive. You first change the sign on the other side and change the inequality. So greater than equal to becomes less than equal to. If both sides of inequalities are positive or both are negative, then on taking the reciprocal, sign of inequality changes. Like for example, if you have 1 by x is greater than equal to 1 by 2. Okay, so if you flip it, x and 2 on both the side, then the sign changes like this, x is less than 2. Sign of inequality does not change when a positive number is added or subtracted from both the sides. So suppose we have a inequality like this, x plus 7 is greater than equal to 6. We can subtract 7 from both the sides. So if you do this, like add a 7 or a subtract a 7, uh, the sign does not, x minus 7 is minus 1. Clear? Uh, Replacement set and solution set. So replacement set is basically the allowed values in a given solution. Like for example, most of the time when you solve an inequality, at the end it would be given to you that x belongs to a natural number or x belongs to a real number. So the set of allowed values are the replacement sets. Am I clear? While solution set is the set of number from the allowed values from the replacement set, which is actually satisfied by that equation. Suppose we have a simple inequation like this, x is greater than equal to or x is less than equal to 5 and x belongs to natural number. So now in this case, x belongs to natural number. Natural number is a replacement set. Okay, so replacement set is all natural number. like 1, 2, 3, 4, 5 till infinity. All natural numbers are replacement set. While what about solution set here? The allowed values, like the values of which is satisfying the condition of the inequation.
So 1, 2, 3, 4, 5.
1, 2, 3, 4, 5. That's it. Because it's a natural number, right? So natural number less than 5. What are natural number less than 5? 1, 2, 3, 4, 5. So in any equation, if they give you like this, x belongs to n. So you need to choose values of x from natural numbers. So that's the allowed values from where you can select. So that's the replacement set. And among the allowed values, the values which is satisfying the given inequation condition is known as solution set. Clear? If x belongs to n, find the solution set of the inequation 5x plus 3 is less than 2x plus 18.
I got
Yes,
I got x is 5.
x is
X is
just 5,
no, x is lesser than equal to 5.
less than
Yes.
equal to 5.
Yeah.
Okay, that's fine. Solve it just like the linear equation. Only thing I keep in mind is don't cancel the negative sign. If you want to get rid of negative sign, just flip it to the other side. Solve it like linear equation. That is rule 1. And second rule is don't cancel the minus sign. Okay. So 3x is less than equal to 18 minus 3, 15. Now we can divide by 3 on either side. So x is less than equal to 5. Now we need to represent the solution set. So solution set is equal to, okay, we just write 1, 2, 3, 4, 5. This is like the previous question. Okay, let's do the next question. If the replacement set is a set of whole numbers, solve the equation. So after solving, what you get final equation is x is less than equal to
So not
3
equal.
bit.
It's only less than.
It's okay, less than. X is less than 1.5.
Yes, sir.
Okay, fine. So what are the allowed solution here? It's a whole number less than 1. So what are the whole numbers? So I think solution set is 0 and 1. That's it. Clear?
Yes, sir.
Now this is the next question. If replacement set is set of real numbers, solve this equation. Okay, now for this question, we need to understand that real numbers are different from integers or whole number, because real number or whole numbers are only complete numbers. Sorry, integers or whole numbers are only complete numbers. Okay, while real numbers can also be fraction numbers, decimal numbers. Okay, so actually between any two integers, there can be only finite number of integer, but there can be infinite number of real numbers. Like for example, between 1 and 5, if I ask you how many integers are there, so you can say finite, 2, 3, and 4. But the number of real numbers are just infinite. In fact, between any two number, there can be infinite number of real numbers. Okay, between 2 and 3, see there's so many: 2.1, 2.11, 2.111, 2.112. Okay, so there can be infinite number of real numbers between any two number. Okay, please simplify this and tell me the final answer. Yeah, what is the equation, Maria?
I got 80. 80.
You got x is greater than 80.
No, yeah, x is greater than 80.
X is
Isn't it
greater than
lesser?
80. I think that is correct. X is greater than 80 is correct. So see,
Opposite of what you did. I took the 9 to the other. I took the 5 to the other side and brought the x upon 5 to the side.
So I got lesser than it. Oh, I wrote the question wrong. So that's what I was like, no, how can it be?
see, I took 5 to this side and brought x by 5 this side. Okay, so here after that we take LCM. 5x minus 4x divided by 20 is greater than 4. Okay, therefore x is greater than 4 into 20, 80. Okay, now, okay, solution set for this. Because for generally for real numbers, we can just write it in a set builder form. Okay, what is set builder form?
So is it that x is to x belongs no x such that x belongs to natural numbers or integers or something, and then
Correct.
you
So
write the values.
So we say a solution set is X such that X is X is greater than 80 and X belongs to real numbers. Please try this question. We can simplify and write this as 12 plus 11 by 6x less than equal to 5 plus 3x. Okay.
Yes.
Next.
11 by 6x minus 3x.
So 11 by 6x minus 3x is
Yes.
less than equal to 5 minus 12. Okay.
Yes. Then
After that,
LCM method, 11x minus 18x upon 6 less than equal to minus 7.
is less than equal to minus 7. Okay.
Then we take the 6 that side, multiplied. So it's minus 7 less x less than equal to minus 7 into 6.
So minus 42.
Yeah. X is less than equal to minus 42 upon minus 7x.
Like this.
Yes.
Then
Then we cancel the minus and 7 is 7 and 7 6 are 42. So x is less than equal to 6.
so ideally, if you do this, when you divide by minus number on both the sides, it is important that we flip the inequality. Okay. So if you're dividing by a negative number, you need to flip the inequality.
Yes.
Okay.
Okay.
So this is greater than equal to 6. Okay. So now the solution set is X such that X is greater than equal to 6 and X belongs to real numbers.
Yes.
That's all. Chalo, one final question for today. Here you see that there are two inequations, one here and one here. Okay.
We divide the equation into two parts and then we work on it.
Yes, that's one way of solving it. You can do the middle term with the first term and then middle with the last. That's one way of doing it. Okay, but we'll learn that in some questions actually it becomes compulsory to do that. But here we will try to do it together. Okay, so let's just write the equation in the improper form because most of the terms are given in mixed fraction form. So we'll convert that to improper form and try to write the inequality. 3 to the x minus 8. So minus 8 over 3 is less than equal to x plus 1 by 3 is less than equal to 9, 10, 10 by 3. Okay. See, our objective is that in middle we just have a x and remaining thing goes to the other side. So how to remove the remaining thing? Like what is remaining here? It's plus 1 by 3 first. The best way to remove 1 by 3 is to subtract 1 by 3. Okay. So we can do this, adding a minus 1 by 3 on with each terms. We learned that in the last rule, right? That if you just add a plus or a minus number to an inequality, the inequality does not change. So what we can do in this next step is just add a minus 3 or a subtract minus 3. Okay. So this is minus 9 by 3 is less than equal to this and this gets cancelled. X is less than equal to 9 by 3. We can simplify this further. 9 over 3 is 3. 9 over 3 is 3. So the final inequation is minus 3 less than equal to x less than equal to 3. So x is a real number between minus 3 and plus 3. Like,
So less than 3, not less than.
oh, okay, sorry. I think I went wrong with the sign from the very first step.
Yes.
So just less than 3. So x is a real number lying between -3 and +3, where -3 is also included. Solution set in the set builder form can be written like this. This is x such that x okay, you write this equation in equation and x belongs to real number. Clear?
Yes, sir.
So that's our final answer. Okay, see you then. Thank you and bye for now.
One
Bye.
Sir.